All right, we're live. Hello, everyone. Hello, everyone, to our audience. And hi, Carlos. Hi, Faisal.
Hey, Jerry.
Hey, so let's just start with introductions. I'll start with myself. My name is Jerry Overton. I'm a DXC Fellow, and I'm head of artificial intelligence in the company. Faisal?
Yeah, thanks, Jerry. My name is Faisal Siddiqi. I'm Innovation Chief Technologist at DXC with an interest in emerging technologies. We're bootstrapping our global blockchain practice these days. We're very excited about that.
Very cool. And Carlos?
Hi, my name is Carlos Guiterrez. My job at Team Penske is to build software tools and analysis tools that allow our racing teams to perform to their maximum potential on the racetrack.
Very cool. So I've been looking forward to this discussion all week. Can't wait for this. And I do want to remind the audience that we are taking questions. In fact, we'll make that a priority. So take a minute, locate the chat window. And if you have any questions, make sure you put those in. And Faisal's going to look out for those, and we'll answer them as they come in.
Yeah.
But while we're waiting for questions, let's do a quick introduction. So Faisal, what's keeping you busy these days? What are you working on?
So I have this really fun job where I get to spread my my interests and my activities across a few different places. Right now, I happen to be in Chicago at a client site, and we're talking about, interestingly, how to use data to do a better job of making. This is going to sound less exciting than racing, but insurance premiums more in line with underwriting rules. And I want to elaborate a little bit on that. But really, this, among other things. The way these things work is not through work that we do ourselves, but with partners. And an interesting thing that we're doing is bootstrapping an engagement program for partners, which we call DXC Invitational, to bring together these interesting commercial interests that we have as DXC, such as insurance or healthcare, with the creative abilities of our partners, particularly startups. So I'm very excited about that, Jerry.
Really cool. What about you, Carlos? What are you working on?
Well, we're just getting ready for the 2019 Indycar season and the IMSA prototype season, as well as the NASCAR season. So at Team Penske, we race a lot of cars, and every week we're trying to prepare for the upcoming race weekend. And we have a big race coming up on the IMSA side at Team Penske, which is the Daytona 24-hour race. So it's the longest race of the season. It's 24 hours long, and we'll share that. Between our two cars, we'll share 3 drivers per car. And then, we have a lot of IndyCar testing coming up. There's a couple new racetracks that we're going to, so we're going to learn a lot from them. And then we're getting prepared for the first IndyCar race in St. Petersburg, Florida, coming up in March. So a lot going on at Team Penske this time of year.
Very cool stuff. So I want to dive into some of that in detail. Me personally, like I said, I'm head of artificial intelligence, and we've been working on a number of projects. One of the cool ones is I've been working with my team on using an AI to create personalized career development plans. And we ran a test of it yesterday, and I of course volunteered my own name. It's kind of surreal to see the bot starting to make class recommendations for me. It came up with a list of, hey Jerry, here's some classes you need to take. So you got to get on it. But out of all of us, I think me and Faisal, we got cool jobs. We're doing okay. But man, I think Carlos, you take it to another level here. So let me see if I can illustrate my point. Faisal, what's a typical day like for you?
What's really exciting is that there are no typical days, and I think we could probably, most of us, say something similar. But if we were to take a look at what is in common, I get to interact with different people on a very regular basis from across the world. The startup engagement program that I mentioned to you really is seeking complementary fintechs and insurtechs and health techs, startup companies that are reimagining the way we do what we do every day. And lots of them bring interesting things like an AI algorithm that they've done to solve a very specific program, or collect data that we normally wouldn't intuitively look for, to identify things like what's going to cost more to buy a commodity or to sell a car or to sell insurance or to stay healthier. So working with those insurtechs has been fascinating in the past 6 months or 12 months or so.
Cool. Okay. So then let me go next. I'm going to share something with you,
Yeah.
share my screen. And I'm talking about, like what a typical day is like for me. So I'm typically taking project. This is a blow up here. What I'm showing you on the screen is the blow up of the what's going on the whiteboard behind me. So I'm typically responsible for taking a problem, breaking it down into something that can be represented in a computer, and then trying to find heuristics or maybe some kind of algorithm to where you can get new insights. So like I mentioned, working with the team on things like what kind of career plan
Hey, Jerry,
do I need?
Did you intend to share your board? Because I'm not seeing it. Carlos, can you see it?
I can see that whiteboard. Yes.
Okay, cool. So please proceed.
Well, so anyway, that's what a typical day like is for me. Now, I'm sharing a picture here of, this is back in June at the DXC 600. Carlos, can you give us an overview of that event? Can you kind of tell us about that event?
Yeah, I mean, you got the opportunity to go out to the DXC 600 last year at Texas Motor Speedway, and really that typical day starts with 6 other typical days, and starting from Monday, we would have gone to another race the previous week, and that Monday is really all about debriefing what happened in this last race, what can we do better for the next race, what are the things that we need to try to tackle for the upcoming week. Tuesday and Wednesday are usually looking ahead, starting to the preparation process, the analysis, the conversion of the information that we have now from this previous event to how we're going to apply that to the next race. Thursday, we finally get to the racetrack, and that's setting up all of our equipment. All those tires that you see back there, we're mounting tires, we're preparing the trailers, we're preparing all the cars, measuring every little detail about the setup, the angles, and things like that about the car.
Okay. So I'm going to pause you really quickly here because I want to slow down when we get to like 24 hours beforehand. So I want to just set the context for the audience, right? So this is on a Saturday, and I'm bouncing around like a tourist, having a great time. For me, this is just a great way to spend my Saturday. But in the background, here's Carlos at work, right? This is his job, right? So he's taken, cool job to another level. This is his office. So, okay. So you're about to tell us from that last 24 hours leading up to the scene that we saw, like how many people are there? Take us through that in detail. What's that like?
Right. So that Saturday we might have done a qualifying session, and so that sets the starting order for our car, for that race that weekend. So we'll get to the track on a race day. So let's just say if it's a Sunday, we'll get to the track, like 6 or 7 o'clock in the morning, and we're rolling out the cars, doing every bit of analysis that we've already done. We're communicating that to the mechanics. We're making sure that the car is prepared to the standards that we want. We're talking to the driver there. You see Simon, and you might not be able to see it very well, but there's some data behind him. And we're going through what we expect the characteristics of the track going to be that day. For example, the temperature is going to rise. I'm sure you remember in Texas, it got up to almost 100 degrees.
Oh, yeah. So you don't forget something like that.
Yeah. So how does the temperature affect what the tires are going to do? And how does the temperature affect, throughout the day as the tire pressures rise and the engine performance compared to our competitors? And not only that, but that race kind of starts a little bit in the evening and then goes pretty far into the night. So is the temperature going to drop back down? And when that happens, do we have to change the characteristics of the car and the strategy as the end of the race comes, towards like 10 o'clock at night? So there's a lot that goes on in the decision-making process between myself, you saw there, the driver, Simon Pagenaud, and then Ben Bretzman, who's his primary race engineer. We communicate all these things to the primary strategist, throughout the race to really make those decisions, to help us maximize our performance.
Yeah. So again, prove my point, right? You take having a cool job, that's like at another level.
Hey, we have a question for Carlos from Tim online. It says, Carlos, will you be at Daytona for the 24?
I will indeed. Yes, I'll be there with Accurate Team Penske.
All right.
Very cool.
Yeah, very cool.
Okay, so Carlos, you kind of trailed off a little bit at the end there, talking about some of the decisions that you make, and I want to pull on that thread a little bit because I want to kind of compare and contrast, like, the way we make decisions and some of the constraints that we're under, and compare that to like the intense situation that you find yourself. So let me start with you, Faisal. You've built systems designed to make decisions, right?
Right.
Can you tell us a little bit about it?
Yeah, and in fact, I'll try to borrow some analogy from the work Carlos does, and at my own risk, of course. I'll end up sounding naive, but also some of the basketball analytics that we're promoting as well. What we find is that there is an opportunity to treat business actors, people who are in the business of conducting commerce, as similar to elite athletes. It's possible, for example, to treat a doctor or a customer service representative or field adjuster and distinguish between the very best and the ones that are perhaps not as good as they are, and observe their behavior in terms of the data that they produce, and provide pointers to others to identify where they could be more successful. We're doing this in a variety of industries, and we can do this simply by observing the behavior of the very best actors in their particular area. So that's been fascinating, Jerry.
Okay, really cool. So, passing the ball back over to myself, I've written systems, designed to make some decisions. I've told you about what we're doing with the HR stuff, and even in, say, financial transactions, being able to flag fraud. So, I get maybe 1 or 2 seconds to decide, hey, is this really Faisal trying to buy a $250 Speedo in the south of France?
That wasn't me.
No, not you. The algorithm's saying otherwise, Faisal. I don't know, man.
Yeah.
But for you, Carlos, decision making kind of takes on like a whole nother level, like new meaning. So I'm showing a car here, and let me set the context, right? So the cars are whizzing by, well, way higher than the 53 miles an hour I have shown here. About how fast do the cars go?
Well, at Indianapolis, we can get it up to speeds of like 237 miles an hour. So they end up going pretty fast at the end of the straightaway.
Okay, so you got cars zipping by an excess of 230 miles an hour. You're in the middle of a race. You have to take in all of these factors. You have to make decisions. So for you, what is decision making like? So my question is, what features do you have to keep track of? What decisions do you have to make? And what are the stakes?
Yeah, I mean, the decision making during the race is pretty intense, like you mentioned, and the key constraint is that we just really don't have a lot of time. We go to some racetracks, like I mentioned, Indianapolis, and the lap time there is about 40 seconds, and every lap we have to make a decision, and then we might go to some other racetracks where the lap time is 18 seconds, even shorter. So, and what I mean by every lap we have to make a decision, we have to decide whether or not we're going to pit. Do we have enough fuel to make it around again? What are our competitors doing? Do we see something that they're taking advantage of on the racetrack that we are not? So your example, Faisal, is that, you try to identify these differences between all these players. And the same thing happens with us. We're trying to see what the other teams are doing, what the other drivers in the other cars are doing. Are they behaving or taking advantage of the racetrack in a way that we're not, such that we can maximize their performance? And then we can choose things like which tire compound we're going to be racing on for the next stint when we come in for a pit stop. Do we need to make any aerodynamic adjustments or any mechanical adjustments to the car? Can we give the driver any coaching throughout the lap to make sure that he's maximizing the performance of the car? So every 40 seconds or every 18 seconds or however long the lap is, we have to give that kind of advice and coaching to the strategist. So it's all about that communication. It's all about that communication between all of the engineering team on the stand, communicating that to the strategist, who then relays that information to the driver and his information back to us. So we're taking in all sorts of data, whether it be timing or weather, the car characteristics as well. And then, we're making decisions based on that information to try to move forward in the running order.
Cool. So what kind of margins for error do you have? Like, give me some examples of, the tolerances that you need to stay within in order to be successful.
Yeah, well, I don't know if you remember at Texas Motor Speedway, but you might have seen those white walls on, around the racetrack had some black marks on them, and those are tires. So the margin for error is really almost nothing. When you come down to situations like that, and to extract the maximum performance from the car, it's within millimeters of the wall that we have to run in order for it to be the fastest lap, so the car's not scrubbing too much speed and that kind of thing. So when it comes down to fuel, when we're making strategy decisions based on fuel, we can measure the fuel in the car down to like, maybe the cup of your hand, 1 cup of fuel. And that's going to make the decision whether or not we go another lap or we're going to get stuck out on track with no fuel. So those are the types of margins that we have to play with, and they're really tight. And having the information presented well to the engineering department and the strategist is kind of the key component for us to be able to make the decisions quickly.
So what's interesting is, when I've had these discussions with you, Carlos, you've talked to me about everything from the history of the Penske organization to, then you'll shift to like, really specific engineering decisions. And then you'll shift to like the specifics of data analysis down to like file compression formats. So what I'm wondering is, what course do I need to take to learn all that?
Oh man, that's just good old fashioned life right there. I mean, I started as a mechanical engineer. That was my formal educational background. I did a lot of work in designing parts for race cars and things like that. And then, I noticed within the past 5 or 10 years that this digital transformation that DXC is leading is really coming into the racing world as well. And how do we capitalize on that? So I started, taking some courses on software development and data analysis and things like that. And I started proposing these different solutions to the team. And ultimately, we started maximizing our performance by looking at the data in different ways, using different tools than we had traditionally. The guys here, everybody, all these engineers are super bright and extremely intelligent. And I doubt that you'll find anybody better at Excel than these guys. So, but there's a world beyond Excel, and there might be some other tools that we can use. And that was what my job was now is to try to introduce those techniques and tools to the race engineers in a way that we haven't done before. And I feel like maybe other teams aren't doing it. And that's our opportunity to, get the edge a little bit.
Cool. And I think a related question to that, I think there's somebody asking about digital technologies. You see that one, Faisal?
Yes, I do. Let's cover that. It's okay. So we'll just start from the first one. Another question from Tim: how do you manage situational awareness with the team during a race? So I'll go for that one, please.
Yeah, that's a great question. Like we said, everything's happening really quickly. And what we try to do is really assign different people on the timing stand a specific role. So you'll have an engineer that's really monitoring all the engine vitals, and he's in charge of making sure that everything that's going on with the engine is correct and safe and things like that. Yeah. The race engineer, his primary responsibility is looking after the vitals of the car and the chassis. So what are the tires doing? What is the suspension doing? Are we going to have any failures? Are we losing performance somewhere? And then you have the data engineer who's looking after all the sensors and instrumentation and data system and logging and telemetry, everything that's going on with the communication to the car for that data. And then you might have a support, another engineer that might be kind of synthesizing a lot of this information and then building recommendations for the strategist to make those calls. So there's a very specific breakdown of the roles and responsibility, and we try to limit the overlap that everybody's doing, and that really helps us make that situational awareness.
Wow. On a related note, you talked about the courses you took starting with as a mechanical engineer. Mike Trusty has a question about digital technologies and skills you've had to pick up on the way.
Oh well, I can tell you the best one. I had the opportunity to go to the Strata Data Conference, and Jerry Overton, my favorite professor, was giving a discussion on AI, and he made the effort to really dive down deep with me and understand how AI might be able to help Penske Racing and Team Penske in at the racetrack. So we started looking at different opportunities for that kind of thing. So those are the opportunities that I think I've taken along the way, whether it be formal education through some data science programs or things online that we can find, but also those face-to-face opportunities with industry experts like Jerry and DXC Technologies is what's really allowed me to at least learn what I need to learn so to help my team.
Hey, and you spoke about AI. Another question from Maureen says, what way do you see automation and AI changing racing? Do you see any of that happening right now?
Yeah, there's a lot of discussions going on in there, and you know, especially with autonomous vehicles and self-driving cars and things like that. And you know, one of the things that I think, which isn't as, you know, spectacular as it might seem, but safety is really one area in which we can really improve the race cars. And when we have enhanced safety through different barriers or different response systems that the car might have, or different you know, safety components that are on the car that protect the driver, we can then start pushing the performance of the car a little bit further. And I think that's where we're limited right now in racing, is just the safety of the environment. And, you know, the cars are capable of going 300 miles an hour, but we're just not ready for that because of the safety of the infrastructure is not all the way there. But yeah, technology from another standpoint can really help, you know, with fan engagement and allowing, you know, right, you to be sitting at home watching the race and feeling like you're there. Imagine you're sitting, you know, on your, you know, with a physical steering wheel in front of you, and you're racing against Simon Pageant on the DXC Technology Penske car in the same race. So you might be able to interact with us in that kind of way. And I think those are some areas where AI and can really push the envelope in terms of fan engagement and the sport as it is. But then, you know, from a nerdy standpoint, from an engineering standpoint, we can get into, you know, how do we optimize the car to a degree that's well beyond what we can do now through AI, or how do we map these physical characteristics that are very difficult to model in real life? How do we map those through some machine learning or regression tools that allow us to really understand what's going on with the car before we actually do it?
Okay, so you're on a really interesting topic, and I want to keep you on this, Carlos, because, you know, Dan Hushin, of course, you know, we all know Dan. He puts out these technology trend predictions, and I am just so surprised at how many of those predictions are really aligning with some of the stuff that you're talking about now. So, you know, having audacious goals and the next generation of the Internet of Things, and being able to take action at the edge. I'm hoping maybe that you'll speculate for us, you know, being an insider into this industry. Can you tell us, what is your vision of the future of racing, and what, if anything, does that have to do with digital?
I think it has everything to do with digital. I think from a selfish team standpoint, digital allows us to kind of beat our competitors. And, you know, one of the things that I think is interesting about racing is we rely a lot on that driver feedback, which is the most critical component, but we're always kind of one run behind. So the driver goes out and does 5 laps, he comes back and talks to us, and then we start making changes on the car and we might get it wrong. You know, the digital transformation for us means that we don't have to wait anymore. You know, the driver can be out on the racetrack. We're watching what's going on immediately. And then, you know, the simulation can be running in real time at the edge with IoT devices that allow us to really start tuning the car before the car comes back in. The driver says, you know, something, it validates what our prediction is. Yep, I got it ready. Now, instead of 20 minutes to make a change, we take 5 minutes to make a change, and we get another run in and improve our performance. And from a selfish team standpoint, I think that's going to be our opportunity to maximize what we do on the racetrack. But from a broader kind of racing standpoint, you know, these tools, like I said, within the fan engagement and other things, allow the fans to be, you know, fully immersed in what's going on. Whether you're a geeky engineer like myself, you're going to be engaged in what's going on with the decision-making process that we have. You have access to the timing information, the weather, what's going to happen when it rains in 20 minutes, who's going to pick those dry tires, and then maybe you can even kind of contribute to the racing experience with, like they have now in the Formula E with the fan boost. You know, they're giving cars different performance based on what the fans are hoping that they get. So
cool. You know, I'm looking here at the questions coming across, and I see a really interesting one about employee race days. And I think what's underneath that is, hey, can you hook us up with some tickets?
I know a guy. I know a guy that can get you some tickets.
I know a guy. Okay, great. So let's talk about how you keep up, right? I mean, all of this technology, you know, the vision that you laid out, fast-paced, you know, fast-moving stuff. How do you keep up?
Yeah.
Well, yeah, without a doubt, and this is not just me saying it. It's technology partners like DXC that allow us to do it, because really, we're just, and I said it in that video, it's just we're a racing team. We have limited personnel, and our expertise is racing, and we rely on people like you, Jerry, and Faisal, that know what's going on in the industry, understand what's going on in these, even with these basketball teams or these other insurance companies, and what is the industry doing for those anomaly detections to see if that credit card transaction is a fraud. Well, we have a similar thing where, how do I detect whether or not the car is going to crash in one lap, which is a very, very anomalous case. So these industry experts like yourself allow us to really kind of bridge that gap and bring it into the world of racing and see how that applies. So that's the only way that we're able to keep up is through those partnerships like that.
Hey, Carlos, we have a really specific question from Jim. Many of us met Simon perhaps in the conference. So Jim's asking, do you have access to a lot of data to adjust the car? And specifically, what data do you have for Simon? He gave it an example. How about shifting or entry into a curve? Does that sound like something that is specific?
Absolutely. I mean, we on the car, we instrumented with hundreds of sensors. And from those hundreds of sensors, let's just give a basic example. Like, we can get like tire pressures and brake pressures and throttle position and steering angle. So we get all these driver inputs. What's Simon actually doing at that moment in time, and what's the car doing? So how is Simon reacting to the car, and how is Simon being proactive to what the car is going to do based on what the tires are doing? So we get a lot of this information. From those 100 sensors, we might be able to deduce on top of that 1,000 different channels. And what I mean by that is, maybe you have 3 points that are measuring the ride height of the car through laser sensors. Well, from that, we have a plane, and now we know what the car is doing from a roll standpoint. I'm going to use my hands from a roll or pitch or things like that, or heave. How's the car moving? How quickly is it moving? And then what kind of mechanical interventions do we need to make with different springs or anti-roll bars to adjust the characteristics of the car to match up what Simon needs from the car?
And okay, so time is just flying by, and I, can't let you out of here without asking you a question about, the wider sports. So, you're very close, obviously, to racing, but you also mentioned, other sports like, possible impacts to basketball and such, and which is really interesting because, the DXC, we've done an article about in The Economist about the effect of data and analytics on the future of basketball. I was hoping maybe you take a little bit of risk here and give us your personal opinion about not just racing, but how do you see the future of sports itself happening? And again, what does that have to do with digital, if anything?
Yeah, and like I said, I'm gonna have to hand that off to Faisal in a bit. But I think, like I said, one of the main areas that ties it all together is how do the fans stay engaged in what we're doing? Because ultimately, we race, for the fans and for our partners and things like that. And how do we keep them, involved in what we're doing and making sure that we're on the leading edge of the technology? And IoT is helping with these kind of microscopic devices that they might be putting in people's shoes to start tracking the behavior. And then from a different standpoint is to, what are the probabilities of this team winning or another team, or how do I build the perfect team, or how do I build the perfect car? And that's where AI and AR and those kind of things are really coming into the racing world and sports in general.
Very cool. What do you think?
I want to take a minute to talk about another team sport. Something that's been on my mind really is that when somebody comes into an emergency department at a hospital or gets choppered in a trauma center, that when we're attending or the physicians are attending to somebody in need, that is a team sport. And the technology associated with that sometimes doesn't really keep up, particularly the data. So one of the things we're thinking about from a healthcare perspective is making the health data available to the people who are on the ground at the time, making life and death decisions about individuals. These are lots of analogous decisions that we have to make across different types of use cases.
Wow, yeah, that's pretty impressive.
Yeah, and I like that, extending this idea of the team, to something outside of sports. I really like that, Faisal. Okay, wow, time has really flown. Guys, we got to do this again. What do you think, Carlos? Did you have a blast?
Anytime, thank you. Yeah, that's a great opportunity to talk to you anytime.
Fantastic. Okay, any last words, Faisal?
I wanted to make a pitch for our DXC Invitational, the Startup Engagement Program. Just a Google search, or we'll send you links. It's for startup partner engagements across industries.
Cool. Carlos?
Yeah, no, thanks for this opportunity. I'm excited to help you guys learn a little bit more about what we do in the racing world, and we hope to see you out at the racetrack again.
Absolutely. Well, hey, I also want to thank the audience. Interaction has been really good. I've been keeping my eye on the group chat. Questions have been pouring in. Thank you so much. Thank you again, Carlos. Thank you, Faisal. This has been great.
Thanks, guys. This has been fun. Bye.
Thank you very much.